Hello, and welcome to today's demonstration of DDX. My name is Jerome Taylor. I'm a principal engineer and chief developer of our DDX and AOX product line. DDX, or Digital Diagnostic Xtreme, is a Nortech patented technology for cable health monitoring. AOX, or Active Optical Xtreme, is a Nortech-designed longer reach USBC hybrid active optical cable. AOX was designed to deliver 250 watts of power delivery plus high-speed data at distances up to 100 meters. Today's demo is a combination of our DDX technology and AOX technology. Let's begin. First, a few words on DDX. DDX is very modular in nature. It employs a series of sensors plus a microcontroller. Combined together, we're able to get cable health information on each end of the cable. In this case, I have module A plugged into my laptop and module B plugged into my camera system. Keep in mind that we're streaming live data simultaneously as collecting health information on each end of the cable. Currently, I'm monitoring temperature, humidity, acceleration, V-bus or bus power, and IMON. IMON is a digital representation of the optical power flowing across the link. Essentially, it measures the strength of the laser diode on the transmit side. If I were to blow on the A end of my cable, the end plugged into my laptop, you should see a change in humidity. And that's represented by the blue line. As you can see, it did rise. Similarly, I can blow on the B end of my cable, or module B, and see a very similar rise in humidity. For temperature, I'll zap one end of the cable only. In this case, the A side. And as you can see, when I zapped the A side with a can of freeze spray, the temperature did go down. For acceleration, we've added a 3-axis accelerometer. It measures movement in the X, Y, and Z coordinate. For simplicity, we display one axis of movement at a time, but you can easily switch between any of the 3 axes of movement. V-bus is a pretty stable power source coming from my laptop. That's represented by the blue line. On the camera end, it's a little lower. There is some variation due to IR voltage drop across the cable itself and the loading of the camera. IMON also is a very stable parameter. As I mentioned earlier, it measures the optical power of the laser diode, and those values should remain fairly constant. Over time, if you do see a dip in the IMON value, it indicates that your laser diodes are starting to deteriorate, and it's something that you should start to monitor. Please keep in mind that while we're monitoring each end of the cable, we're also streaming live data simultaneously. The firmware in each end of the cable for the modules, the DDX module, is configurable. You can add alerts, flags, you can change the sample rate, you can add other types of diagnostic hooks for advanced cable health monitoring, such as predictive failure or predictive maintenance. The GUI that I'm showing you is just a sample application. We can provide it in sample code, or you can use it as is, or you can develop your own. The firmware inside the DDX modules themselves is also configurable. You can update the firmware to issue alerts and flags, or change the sample rate, or add analytics for predictive failure analysis. Again, DDX is the foundation for what we call our smart cable technology. It allows you to proactively address issues versus being reactive in nature. This concludes my demonstration of DDX. Thank you for your time.